All right. The next few sections are kind of shortish, easy-ish sections. This section 4.6 is on adding and subtracting with radicals, and I'm just going to do a few problems without letters with square roots, just so I can show you on your calculator kind of the concept, and then I'll do the problems from the section that you might not be able to use your calculator on. So let me do something like this. 3 times the square root of 2 plus 5 times the square root of 2. I'll do this on my calculator. It will be obvious how to do it by hand once my calculator spits out an answer. So 3 square root of 2 plus 5 square root of 2, and you magically get an answer of 8 square root of 2. I'll do another one that's kind of similar. How about 7 square root of 15 minus 4 square root of 15, so a subtraction as opposed to an addition. Maybe you could already guess what the answer is, but I'll do it anyways. 7 square root of 15 minus 4 square root of 15 equals 3 square root of 15. So you can add and subtract square roots if the radicands are the same. I'll show you something with a different radicand, like 3 square root of 2 plus 5 square root of 7. And I'll do that on my calculator. Do 3 square root of 2 plus 5 square root of 7. And I magically get, well, it changed the order on me. I don't know why it did that, but it did. But my calculator knows that these can't be added. In order to add or subtract with radicals, you have to have exactly the same radicands, and even more specific, you can't add a square root to a cube root. So if I was given a problem like 3 times the square root of 2 plus 5 times the cube root of 2, my calculator couldn't show me that you can't do this because it just doesn't know how to work with cube roots other than turning them into decimals. But these also can't be added. So in this section, most of the problems we're going to be able to, they're either going to be given in a style that they can be added, or we'll be able to do some of the stuff that we did in section 4.5 to make them something that we can add. So just with these kind of ideas in mind, if you have the same numbers under the radicals, you add by adding the numbers in front of the radical doesn't change. Similarly, you subtract by subtracting the numbers in front of the number under the radical doesn't change. And if you have different numbers under the radical, they can't be added or subtracted. And even if you have the same number under the radical, if they're not both the same index, you can't add or subtract. So that's everything in this section. And then we just have a lot of examples that kind of hammer this down. The first problem is, I don't know, it's a little bit harder than some because there's a number that's not written that's assumed, but these can be added. I certainly couldn't do these on my calculator because of the x, but they definitely can be added. And when I add them, the square root of 2x isn't going to change. I just have to add the numbers to the left of each of the radicals. And that first radical, it didn't have a number written. And when that happens, when you don't have a number written, then there's an assumed 1 in front of that radical. So for an answer to problem 2, I have to add the 1 and the 3 that's to the left of each of the radicals. And my answer is just going to be 4 square root of 2x. When I'm adding or subtracting, if I have the same radicands, and they're both square roots or both cube roots, then you just add the numbers outside the radicals. So 4, I couldn't do on my calculator because of the fourth roots. My calculator would turn this into a decimal, but it's not that hard to do by hand because really the only thing I have to be able to do is subtract the numbers in front of the radicals because the radical part's not going to change. So in my answer, I'm still going to have that fourth root of 5. The number to the left of the radical is going to be a 5 because the 7 and the 2 in front of the radicals subtract to be 5. And that's all there is to do for 4. In 6, I have 3 cubed roots, They all are cube roots of 3, so I can condense these to one radical with a cube root of 3 if I combine the numbers to the left of each of the radicals. The first radical didn't have a number in front of it, so there's an implied 1. I'm going to go 1 minus 3 minus 2, and whatever that equals, I'm going to put in front of my cube root of 3. So 1 minus 3 minus 2. I'm going to put a negative 4 to the left of my cube root of 3, and that'll be my answer. So the first few problems in this section are really nice. They're just, essentially you could do them in your head quickly. The next problem 8, it's a little bit tricky in that when I look at the things under the radicals, they're not all 3 identical. So the very first piece, this can't be added to the next 2 pieces, because in order to add or subtract with square roots, cube roots, fourth roots, you have to have exactly the same radicands. And because y is not exactly the same as 2y, these can't be, all 3 can't be added, but these can. So in my answer, this 3 times the fourth root of y, that's going to be part of my answer. It's not going to be combined with the other 2 radicals. The other 2 radicals, the first one has that 1 that's implied, a positive 1 that's implied in front of it. The second one has a 3. So I'm going to add the 1 and the 3 and get a 4. And for an answer to this, I'm going to write 3 times the fourth root of y plus 4 times the fourth root of 2y. It would be illegal to get a 7 here. You can't add radicals unless they have exactly the same radicands, exactly the same, exactly identical, not close, but have to be exact radicands or numbers under the radicals. 10 is supposed to be cube roots of that 3. It's not completely clear whether that 3 is a cube root or an exponent on the 3. It kind of looks like both. That's how the software makes cube roots. So I'm going to consider this as 3x times the cube root of y minus 7x times the cube root of y. It doesn't, I guess if you thought each as an x cubed, you'd get an answer that I'd have to deal with and say it's correct. Because they both have a cube root of y, they're subtractable. And in order to subtract, you have to subtract the numbers outside the radicals. 3x minus 7x can be subtracted, and just like when you're subtracting with radicals, the letters don't change, just the numbers in front of the letters. So 3 minus 7 is going to be negative 4, and the letter doesn't change when you're subtracting, nor does the radical part change. So this answer is going to be negative 4x times the cube root of y. Ugh. This is supposed to be, again, cube roots. This is supposed to be 5, 6y times the cube root of y minus 4/5 y times the cube root of y. So again, they both have the same radicands, so I can subtract. What I have to subtract is 5, 6y minus 4/5 y. The y part's really not the interesting part. That's not going to change, and that doesn't really impact my subtracting. I need to be able to subtract 5, 6 minus 4/5, and I could bust my calculator out to do that if I don't want to take the brain cells to do it by hand. So here's 5, 6 minus 4/5. That's going to be the number that goes in front of the y. It's going to be 1/30. So for my answer, subtracting the fractions, I get 1/30. When I do the subtracting, that y doesn't change, nor does the radical change. So I'm going to get 1/30 y times the cube root of y. If you felt guilty and you wanted to do the fractions by hand, it's not hard. What I would have done if I was doing this by hand is multiplied the 5/6 by 6/6 and made that, by 5/5 should I say. I would multiply the 5/6 by 5/5, and I'd make that 25/30y. And I'd multiply the 4/5 by 6/6 and make that minus 24/30y. And then I'd subtract the 25/30 minus the 24/30. And the 30 part doesn't change. You just subtract the 25 and the 24 and you get the 1/30. I generally can do fractions well enough that I don't resort to my calculator, but if your calculator is a lot quicker and more accurate, I don't have a problem with you, using your calculator to do the fraction work. 14 looks like the first problem where I'm just done. Those can't be added the way they're written. Unfortunately, that wouldn't be a good enough answer. If you're presented with an addition problem with radicals and there can't be added the way the problem's written, you have to do the prime factor reducing and see if after you reduce it they're simplifiable. So I'm going to reduce the cube root of 40. I'm going to do a prime factor tree for 40. 40 as a prime factor tree is 2 times 2 times 2 times 5. And so this cube root of 40 is going to reduce. I box the 3 2's. I'm going to get 1 2 in front of the radical and a 5 under the radical. Now I'm going to do the same thing for 135. I'm going to do a factor tree for it. So I go 135 equals shift in the quote key. And 135, according to my calculator, equals 3 times 3 times 3 times 5. It's cube root, so every time I get 3 of a kind, I box them and get 1 in front of the radical. So the cube root of 135 is reducible. You get a 3 out to the left of the radical and a 5 under a radical. And now that I've rewritten each of the cube roots, I've produced something that can be added, and my answer is going to be what I get when I add these two. I'm going to add the 2 and the 3 and leave the 5 alone. So this is just going to be 5 times the cube root of 5. If I didn't attempt to reduce the radicals, I just stopped and said they couldn't be added, then I'd be wrong. 16 is a similar problem. So I'm going to reduce each of the radicals. They're 4th roots, so I need 4 of a kind. First one I'm working on is 48. So I go 48 equals shift. And so 48, according to my calculator, is 2 times 2 times 2 times 2 times 3. 4th root, so I need to box 4 to get 1 outside. So for the 4th root of 48, I get a 2 outside my radical and a 3 under my radical. Now I'm going to work on the 243, so I'll go 243 equals shift in the quote key. It says 243 is 3 to the 5th, so it's 3 times itself 5 times. For reducing, it's a 4th root, so every time I get 3 of a kind, I get 1 out front. The 4 out front of the 243 stays there. In addition to that 4, I'm going to get a 3 out front and a 3 under the radical, because every time I get 4 of a kind, I get 1 out front. Anything that's not part of a 4 of a kind stays under. So I almost am at the position now where I could subtract, make the 2 radicals into 1. I just need to multiply that 4 and the 3 first. So now I'm going to get 2 times the 4th root of 3 minus 12 times the 4th root of 3. To finish up the problem, I just have to subtract 2 minus 12. And 2 minus 12 is negative 10. So in my answer, I'm going to have a negative 10 outside the radical and a 4th root of 3 for the radical part. Ooh, 18, I have to do a bunch of work. I have to work on, from the first radical, the 54 and the y to the 5th. From the second radical, the 2 and the y squared. So I need to try to reduce each of the radicals because they can't be subtracted the way they're written. So I'm going to get the 54, 54, enter, shift, factor that thing. So this is 2 times 3 cubed. So for the 54, I'm going to get a 3 outside the radical and a 2 under the radical. And there's already a 3 out there. So I have a 3 that starts out in front of that radical. I'm going to pick up another 3. And I'm going to leave a 2 under that radical. For the y to the 5th, I write down 5 y's. And I'm able to make one group of 3. So I'm going to get 1 y outside the radical, and the 2 y's that are left over stay under the radical. If I want to clean this up a little bit, I can multiply the 3's outside the radical and make a 9y in front of the radical, and then it's the cube root of 2y squared. This is already simplified enough. If I look at the other radical, the 2 doesn't, in its prime factoring, because its prime doesn't have a 3 of a kind. The y squared doesn't have a 3 of a kind. The second radical doesn't reduce at all because there aren't any 3's of a kind. But that's okay, because my radical parts already match, because now they both are cube root of 2y squared. So to finish up the problem, I just have to subtract 9y minus 2y. And when I subtract 9y minus 2y, I just subtract the 9 and the 2. The y's don't change. So for my answer, I'm going to get a 7y in front of the radical, and the radical part doesn't change when you're subtracting. It's going to stay 2y squared. Okay, I'll keep going. All these problems are more or less the same. If you can reduce the radicals well, then the problems aren't hard. That's kind of going to be the case for the next couple sections. If you're competent at reducing radicals, then you're going to do really well. If you're not competent at reducing radicals, then you're going to get slowed down. So, first radical in this one has an a and a b squared. Second radical has an a cubed. I'm going to try to reduce both radicals first. The first radical already has a 3 and an a squared and a b out front. When I look at the a, there's not a pair of a's, so it has to stay under the radical. And if I look at the b squared, if I expand it, I'm going to get 1b in front of the radical, and no, there's no b's left over to put under the radical. So I'll get a b out front and an a under for that first radical. The two b's that I have out front I can multiply together and make a b squared. So I can write this as 3a squared b squared times the square root of a. The second radical has an a cubed under it. And that a cubed is going to make me have an a outside the radical and an a under the radical. So I already have an ab squared out front. I'm going to bring an a out front and leave an a under. The a under, I'm just going to leave it under like I might normally. The a out front, I'm going to write to the left of the a rather than after the b squared. Multiplication is commutative, and it just makes it easier to see the simplifying. So the a that I brought outside the radical needs to be multiplied by the a that's already there. When you multiply those a's, you get an a squared. It might be nice if I put a number with that radical so you can see what needs to be subtracted. So I'm almost done because they both have square roots of a's. So now I just have to subtract 3a squared b squared minus 1a squared b squared. And I'm just going to subtract the 3 and the 1. When you're adding or subtracting with variables, they don't change, just the coefficients change. So for an answer, I'm going to have a 2, and then an a squared and a b squared, and also that square root of a. Okay. Both of these radicals I need to take a stab at. First radical I have to deal with the 16 and the x. Second radical I need to deal with the 81 and the x. Need 4 of a kind to get something out front. So for the 16, its prime factoring is 2 times 2 times 2 times 2, which means it's a perfect fourth root. That I'm going to get a 2 in front of the radical, and I'm not going to be left with a number under the radical because there's no stray number after the 2's. The x, on the other hand, is going to stay under the radical because there's not 4 of a kind. Bring down my plus sign. Now I'm going to work on the 81. 81 is 3 times 3 times 3 times 3. It's a perfect fourth root again. So for the second radical, the numbers are going to work where I'm going to have a 3 outside the radical and no number left under the radical because there's nothing after the 3. So I'm bring down my plus sign. I have a 3 under a radical, outside the radical. And this x, because there's not 4 of them, I can't bring the x out front. It stays under the radical because you need 4 of a kind to get an x out in front of a radical. These are good enough to add because they have the same things under the radical, so I'm just going to add the 2 and the 3. My answer for this is going to be 5 times the 4th root of x. So if you're good at reducing, then the adding and subtracting is kind of trivial. So hopefully after you did section 4-5, you get pretty comfortable with reducing the radicals, and you're just kind of blowing through this section. If you're having a really awful time because you can't reduce the radicals, you should watch the 4-5 video again, and it goes, in great detail on how to reduce each of the radicals. Getting to the end of this section because it only goes up to, 28, so just 3 more problems. So in 24, I have to reduce the 50, the x, and the 8, and the x. When I do the 50, the prime factoring for 50 is 2 times 5 times 5. For the 50, I'm going to get a 5 in front of the radical and a 2 under the radical. And the x from that radical stays under because there's not 2 of a kind, and you need at least 2 x's to get 1 in front of the radical. Do the same thing for the 8. 8 is equal to 2 times 2 times 2. So for the second radical, I'm going to get a 2 out front and a 2 under, because once I get a pair of 2's, I get one of those out front, the single 2 stays under. So I'm going to get a 2 out front and a 2 under, and for the second radical, there's not a pair of x's, so the x stays under. Now I have the radicals lined up perfectly because they both have square roots of 2 x's, so I just add the 5 and the 2, and my answer is going to be 7 times the square root of 2x. 2 more problems. First radical just has a y under it. That's going to stay under it. It's not going to reduce. Second radical has a y cubed. It's a square root, so I need 2 of a kind. Second radical, I'm going to get 1y outside the radical and 1y under the radical. So first radical, it stays 2y square root of y because there's not a 2 of a kind. Second radical becomes y square root of y. Might help for me to throw a 1 in front of that so I can see what I'm subtracting. What I need to subtract is 2y minus 1y, and 2y minus 1y is going to be 1y. So I can write 1y square root of y for an answer, or just y square root of y for an answer. And most authors wouldn't write the 1, but it's definitely not wrong to have it. It's maybe almost helpful to see it there. All right, last problem. 3 radicals, really kind of unfortunate. First radical has a 2 and an x, and these are cube roots. There's not 3 2's, there's not 3 x's. The first radical doesn't reduce. I'm going to emphasize that there's a 1 in front of that x. It might help me. So I get 1x cube root of 2x. Bring down the minus sign. Now I'm going to work on the 16 and the x to the 4th in the second radical. So 16 equals shift, factor it, it's 2 to the 4th. So for the 16, because this is a cubed root, I'm going to get 1 2 in front of the radical for the 3 2's, and 1 2 that's left over under the radical. So numerically, I get a 2 out front and a 2 under the radical. In that second radical, the x to the 4th works the same way. You get 1x in front of the radical, 1x under the radical. Third, I have to deal with that 5 that's in front of the radical, and I also have to work on the 54 and the x to the 4th. So I'll work on the 54 first. Prime factoring for 54 is 2 times 3 times 3 times 3. So the 54, you get a 3 in front of the radical and a 2 under the radical. For the x to the 4th part of that, you get 1x in front and 1x under. I'm going to multiply that 5 and then 3 and get a 15. So I have 1x times the cube root of 2x minus 2x times the cube root of 2x plus 15x times the cube root of 2x. They all have a cube root of 2x, so I just have to go 1x minus 2x plus 15x. The x part isn't going to change, so I really just need to do 1 minus 2 plus 15. And actually do it with a minus. 1 minus 2 plus 15. I get 14 as the number part of my answer. That goes in front of the x cube root of 2x. So for my answer, the numbers turn into a 14. The x part doesn't change, nor does the cube root of 2x part change. It's kind of fast. You can always pause my videos if I'm going too fast. You can rewind, watch again if it felt a little bit quick. But if you're comfortable reducing the square roots, cube roots, and fourth roots, then the section probably wasn't baffling to you, because it's a real friendly section. Once you get the radicals reduced on the ones that weren't addable or subtractable to start, they just kind of break down really quickly. So that's that whole section. The next section's on multiplying with radicals. We did some multiplying already. In the next section, we're going to do some foiling and more complicated multiplying, but it's also a pretty friendly section. It's probably equivalently difficult to this last section. So if you did well with this section, you'll do well with the next section. Again, the keys are going to be your ability to reduce the radicals. And if you're not feeling good about that, watch the video on 4-5 or come visit me in my office, and I can sit down and help you out and figure out what you're not understanding.